Okay, let's finish out the material that may be on the that's eligible for the first exam by doing the integumentary system. This is chapter 6, and then we'll be all done for the material for exam 1. And I should be able to do this this system in one video lecture because it's well, it's a relatively short chapter, and we're not doing the whole chapter. So let's start. The parts, the integument, consists of an epidermis and a dermis. And a hypodermis shouldn't be underneath the integument. That's actually underneath the integument. I'm going to show you a diagram of that later on. And so what the functions of the skin and integumentary system are in the later part of the chapter, but I think we put up front, resistance to trauma and infection. So really your skin is also part of your immune system. And as a barrier to dehydration. We mentioned this before, vitamin D synthesis, the first part of vitamin D synthesis, UV radiation converts a molecule in your skin to a precursor to vitamin D that I think has to go to the liver and the kidneys, and finally we make vitamin D. And so everybody should be outdoors for at least like 20 minutes to get enough vitamin D. Also sensation. We got all kinds of sensory receptors underneath the epidermis. They're not in the epidermis, they're in the dermis underneath. And all kinds of soft touch receptors, deep touch receptors, heat receptors, nociceptors, pain receptors, all kinds of receptors. And we'll talk more about those actually when we get to the senses chapter. Thermoregulation. What does that mean? Well, there are the amount of blood that goes to your skin is really variable. You can send just barely enough to keep the cells alive, right? And that helps to conserve heat. So on a really cold day, you'd be doing that. Or you can send lots more blood to the surface on a really hot day. And you can release, there's a way to release excess heat. Nonverbal communication. You know, that's part of the skin, particularly the skin of your face. Okay. The epidermis. Keratinized stratified squamous epithelium is what the epidermis is in the integumentary system. Its cells, well, there are some, well, I guess you can call them stem cells. It's a basal layer of cells that are always going to mitosis. They're always going to mitosis. That's why skin cancer, for example, which is uncontrolled mitosis, is much more common than, say, brain cancer, because brain cells don't go through mitosis once you're an adult, that is. So, so they can consider like pluripotent stem cells because they can become any one of these other kinds of cells. Keratinocytes, which is the normal skin cells. The melanocytes, which are the cells that provide your skin with its color. Tactile cells, which wait a minute. Okay. I think that's more immune cells. We're going to talk about those. I think they have another name. We'll get to that. Okay. Dendritic cells. This is part of the immune system. Remember, dendritic cells are like the border guards that are line mucous membranes in your skin to be the first line, well, the part of the second line of defense in the immune system. Remember, your skin is the first line. Second line is these dendritic cells, and they're phagocytic. Okay, there are 4 or 5 layers of the cell. you're not going to know, have to memorize the 4 or 5 layers, uh, their names, but just know that there are 4 or 5 layers. The dermis underneath the epidermis. Now, remember, the epidermis has no blood vessels, no nerves. That's true for all epithelia. Right? And the dermis has a papillary layer that's closer to the surface, composed of areolar tissue. And it's going to be all kinds of sensory receptors and bases of hair follicles and sebaceous glands and sensory receptors, all kinds of things in there. And then below that is a reticular layer. And that is a mostly dense irregular tissue. And there can be blood vessels down there, because this is what blood vessels would be. And then underneath the dermis is the hypodermis, which is mostly, I mean, certainly blood vessels and things down there, but it's mostly fat, adipose tissue, subcutaneous fat. So you have this layer of subcutaneous fat all over your body, just in your dermis, underneath your dermis, right? Called the subcutaneous layer or the hypodermis. And there it is. And this is right there on page 188. As you can see up here, the whole thing is called the integument, and the subcutaneous layer is underneath the integument. All right. Okay. And the integument consists of the epidermis, right up here, which is a epithelial tissue, and then the dermis underneath, which has the papillary layer up here, which remember is areolar connective tissue, mostly, and then the reticular layer down here, which is dense irregular connective tissue. And you can see all of the things in the dermis. Sweat glands, sebaceous glands at the base of hairs, erector pili muscles, which are these vestigial, well, they still work, but they don't work. They were originally designed to make us look a little larger and more fearsome if we still maintain the hair all over our bodies. But we don't. We have hair all over our bodies, but it's really fine, and it just causes goose flesh. So it's really kind of a vestigial thing. And all these sensory receptors, like I said, for touch, and temperature and pain, so on and so forth. And here's all these blood vessels down here also. Okay, and okay, so, and remember the subcutaneous layer is mostly, I mean, there's other stuff down there, but mostly it's adipose tissue. Okay. Here we can peel up the epidermis and see the epidermal ridges that fit into the dermal papilla. Okay, the lines of cleavage, orientation of collagen fibers along certain lines. And these are used by surgeons when they want to cut into you. They try to cut along these lines and then sew you up so the scars are not really as bad. Cut across the lines, you're going to end up with a pretty bad scar. Striae are when you stretch the skin too much. So perhaps when a person who gets really obese or pregnant women often get striae because their abdomens are stretched out so much. And when they give birth, those lines are still there. Okay, dermis, innervation. Sensory nerve fibers innervate the dermis. In vasculature, we have vasoconstriction and vasodilation. As I mentioned before, we can bring a little bit of, we can vasoconstrict and only bring a small amount of blood to the surface and we want to conserve heat. Or we can vasodilate and bring lots of blood to the surface on a really hot day. Okay, here is the epidermis and those cells I was mentioned. Here are these. Okay. So the tactile cells. I was going to tactile cells are connected to sensory nerve endings. So they get pressure sensations, and they probably synapse with the sensory nerve endings and send information. You know. And this is on, let me read more about those. This is on page 189. Yeah, tactile sounds sensitive to touch when compressed. These chemicals that stimulate sensory nerve endings. So they have synapses with the sensory nerve endings. You have the regular keratinocytes, which are the ones in the dermis are living. The ones up here in the epidermis, no, that's not dermis. The ones in the lower part of the epidermis are living. The ones in the upper part of the epidermis are dead. Remember, as they get pushed up, this basal layer here is always going through mitosis, and these cells get pushed up and pushed up and pushed up, and they get farther and farther away from the blood supply, and therefore they start to die. And when they die, they start making lots of keratin, and it becomes really bags of keratin when they're on the very top and they're dead, and they get sloughed off all the time. Okay. As I said, you don't have to memorize these stratums here. What stratum in what order? I'm not going to hold you to that, but just know that there are 4 or 5 layers, depending upon thick skin or thin skin, which we'll get to. Then we have these dendritic cells over here that are phagocytic and part of the immune system. And then we have a melanocytes right here, which are the cells that give color to your skin. And we'll look at skin color later on, and all different kinds of skin color. But the basic skin color, it's called a polygenic inheritance because it's controlled by lots of genes. And it really, and the evolution of skin color is really interesting. And maybe we'll get into that if we have time. But anyway, the interesting thing is, no matter what your skin color is, how light it is or how dark it is, you have the same number of melanocytes per cubic centimeter skin that anybody else has. Same number. So why are different skin colors? Depends upon how active those melanocytes are. If they're because they make melanin and they give it to the keratinocytes. And if they're not very active, you have a light skin color. If they're very active, you have a darker skin color. Something else also interesting about sweat glands. Everybody has the same number of sweat glands per cubic centimeter of skin, everybody. But how active are they? And how active they are, how many of them are active? Not how active they are, how many of them are active? Well, that's determined by where you spent the first 6 years of your life. You spend it in a real tropical climate, they're like almost all active. And when you get overheat a little bit, you send out, each one works a little bit and gives you a nice sheen of sweat where you can thermoregulate that. The farther north you grew up, the fewer and fewer are active. And then when you get really hot, they have to like make huge amounts they have to really be extremely active, and they make the droplets that form on your skin fall off. And that's me. I spent the first six years of my life in Quebec, a frozen Northland, and I have very few active sweat glands. So when I get really overheated, I make huge drops of sweat that fall off, rather than a nice, sheen across my skin. But that's what. It was discovered actually by a Japanese scientist in the 30s, who actually experimented on himself and probably also experimented on Chinese POWs. So it's probably a war crime, but he's the one who discovered this. Okay, that's really aside. Okay, So skin, thick skin, thin skin. So thin skin's all over your body and it has 4 layers. Thick skin on the soles of your feet and your palms, and there's hair all over the thin skin. There's no hair on thick skin, and it has 5 layers rather than 4. And it doesn't have any sebaceous glands. So no sebaceous glands. Well, that's because sebaceous glands are associated with the base of hair follicles, and there's no hair on your palms and in the soles of your feet. Okay, skin markings, nevus or mole. This is a localized area where the melanocytes are a little bit more active. So they leave a dark area in the skin. Freckles is very similar, but not so much so, okay. Hemangiomas are reddish areas because of open capillaries or something, and a lot of times the little children are born with these red areas over the skin, and mostly they leave. But sometimes they stay throughout your entire life, and these are called port wine stains, and they're not dangerous or anything, but they're just something of a hemangioma that doesn't go away. Friction ridges, fingerprints. That's what fingerprints are, friction ridges. Skin color. So due to the actions of melanocytes, that's your basic skin color is how active your melanocytes are. Changes, blue cyanosis. Your skin's not getting enough oxygen, it's going to be turning blue. And that's an indication that something really wrong. Red, erythema, is irritation, like it's damaged or got inflamed somehow, it turns red. Yellow is jaundice. Your liver is not breaking down the byproducts of red blood cells well enough. And these really biopigments are not, they're not being put into the gallbladder and they spread throughout your body and turn your skin sort of yellowish, and the whites of your eye becomes a little yellow too. Purple is hematoma. That's really when something struck and breaks blood vessels. A bruise. Whiter, pallor. If you go on a really cold day, you become a little lighter. Even African Americans become a little bit lighter. And then whitest is albinism, essentially absence of color. But this is a genetic disorder, and even your the irises of your eye aren't colored, and their eyes are red colored. Okay, sweat glands, or sudoriferous glands. This is part of cutaneous glands. And there's 2 kinds, eccrine, also known as merocrine, because they operate in a merocrine way. They just exocytose the sweat. And they're found all over your body. And they are primarily for thermoregulation, all right, to cool you down. But then the apocrine sweat glands, and they're called apocrine because they thought that they acted in the apocrine way. Remember, the apocrine way is the top part of the cells break off, that becomes them. It's not true. They actually all work in the merocrine way, but they still call them apocrine to distinguish them from the eccrine use of thermoregulation, because these ones have something very different in mind. You only find these around your nipples, in your armpits, in your anus, and near your genitals is where you find the apocrine sweat glands. And they secrete a fluid that is that has some oils in it, and bacteria act on those oils and cause odors. These are so they cause odors, and most of the time we try to hide those odors with deodorant and other things. We try to hide those odors, and sometimes those odors are not pleasant because we wear clothes now, and in enclosed spaces, But actually, when when we were running around outside naked, these odors were actually sort of different and actually thought to be sexually attractive. These are aphrodisiac smells. It was thought. So one time it was really stimulating. Now we try to avoid them. Okay. Sebaceous glands at the they can make so they make this oily substance at the base of hair follicles. So this gives you a nice oil over your skin and keeps your skin moist and supple. And that's why soap. When you use soap, it solubilizes these oils and takes them away. And that's why soap dries your skin. They also make sebum. You know that yellow stuff that may form in your eyes after a night. That yellow stuff that's made by sebaceous glands. Cerumen in your ears, ceruminous glands. They make cerumen, which is earwax. And what's the function of earwax? Probably protection. And of course, mammillary glands. These are apocrine glands, and they're really modified sweat glands. They're similar to the apocrine sweat glands, but much more sophisticated in the things they put in their fluid in mother's milk. Sugar and oils and carbohydrates and all kinds of nutrients and antibodies in mother's milk. Okay. Skin cancer. And I said skin susceptible to cancer because it goes through mitosis all the time. And the more time you go through mitosis, the more possibilities of you having something going wrong, right? And the skin cancer carcinomas, skin cancer in the regular keratinocytes are called carcinomas. And generally, they can be cut out. They grow, form small tumors, you just cut the tumors out, no problem. They don't become malignant. It's the melanoma. For some reason, the melanocytes, if they become transformed and become cancer cells, they're the ones that metastasize and it become malignant skin cancer. So those you got to really worry about. That's why whenever you should monitor your moles. Look at them. If they ever start really changing shape, changing color, get to a dermatologist ASAP. Because remember, if you can get them before they metastasize, your prognosis is good. You wait till they metastasize, now you have to go into chemotherapy, and your prognosis is much less, and it's much more dangerous. So why are melanocytes this way? I don't know. Well, that's it. That's it for integumentary. Now look, there's a lot more. Let me look at the glasses. In this chapter, I didn't go over. And let me go over that to make sure you don't spend a lot of time on that. And that is, okay, integumentary structures derived from epidermis. So on page 200. So go into hair and go into fine details in anatomy of hair. We're not going there. Don't worry about that. Hair structure. Hair color, this we're not doing. And is anything on nails? No, we're not going to do with the nails. Acne, we're not going there. Repair and regeneration. Skin is really repairable and great regenerative capability. That's all you really got to know. We don't have to go through the stages of the repair. And Burns, we're not going to Burns either. Or development of the integument, or even aging of the integument. Those you can pretty much skip over. So like I say, we're only doing part of this chapter. And so that's it. That's it. So this will be, just 203 integument for this video lecture. And that's the stuff, and that's the material, like I keep on saying, for exam 1. So we can close up shop here, and I'll see you later in later chapters for the stuff that'll be in exam 2. Okay, see you later.